We have two powerful tools that let us solve equations. Let's look at the first one of them. The addition property of equality. And this basically says the same real number or algebraic expression representing a real number may be added to both sides of an equation without changing that equation's solution set. Okay, I can add the same thing to both sides of an equation and it will still have the same solution set. More explicitly, the equations A equals B and A plus C equals B plus C are equivalent. Okay, those two equations have the same solution set, so long as that term C is a real number or an algebraic expression representing a real number. Also, since real numbers are all the guys that we care about to a large extent here, the equations A equals B and A minus C equals B minus C are equivalent as well. And why can I do that? Well, instead of C, I could add negative C, and negative C, adding negative C is the same as subtracting C. So here I go, right? Here is the additive property or addition property of equality. If I've got an equation, I can add the same thing to both sides and keep the same solution set. Just a couple of quick, short examples of using this. Here I have x minus 5 equals 21. So I can add 5 to both sides of this equation. Now, I chose 5 because if I add 5 to x minus 5, when I simplify the left side of this equation, I will now get just x. When I simplify the right side of this equation, I will have 26. And if this equation I just made is equivalent to that equation up there, then 26 must be the solution for that equation up there as well, because they're equivalent. And I can see that the only number that's going to make this equation true is 26. So for that equation on the bottom to be true, x has to be 26. And since these guys are equivalent equations, 26 must also be the solution to that top one. Now, I am not above making an algebraic mistake or an arithmetic mistake at some point. So I always want to double check. Is it 26? Is 26 the only element of the solution set? Well, I can check that by going back to my original guy, taking a breath, and saying is 26 minus 5, 21. Let's see. Yeah, 26 minus 5 is 21. Great. 26 is my solution, or the solution set of this equation. It's the set with just the element 26. Okay, let's look at another one. Here I have x plus 9 equals 4. Well, again, I want to get rid of that 9 because if this was just x equals something, it'd be really easy to see what the solution was. So I'm going to subtract 9 on this side. And this will only stay an equivalent equation if I subtract 9 on this side as well. When I take x plus 9 and then subtract 9, I'm just going to be left with x, because whatever number that was, if I make it 9 bigger and then make that 9 smaller, I'll just be back where I started. Now on the other side, 4 minus 9 is the same as the opposite of 9 minus 4, which is 5, so this is negative 5. So, since the solution to this is definitely x is negative 5 is my solution, negative 5 satisfies that, it's my belief that the solution to this is negative 5 as well, because again, these two guys are equivalent. They stayed equivalent because I used the addition property of equations. A quick check. Is it true that negative 5 plus 9 is 4? Well, if it's negative 5 degrees out and it warms up 9 degrees, I'll be at 4 degrees. So that works out. The answer to that question is yes, that equation is true. That means negative 5 satisfies my equation, and negative 5 is a solution to x plus 9 equals 4. Great, let's do another one. Here I have negative 15 plus 6x equals 7x. Now again, if this was just x equaled something or something equaled x, I'd be good. I'd be done. I'd be able to see right away what my solution was. So I can get there by simply subtracting 6x from both of these sides. Okay, so negative 15 plus 6x minus 6x will just leave me with negative 15, because no matter what x was, not sure why I just erased part of that negative sign, but no matter what x was, if I take 6 times it and add it, and then take 6 times it and subtract it, I'll be left with whatever I had. And then 7x minus 6x will leave me with 1x, or just x. Looking at this, it would appear that negative 15 is the solution to this equation, and the only solution. And again, since I didn't do any, since I followed the rules, since I kept equivalent equations, the solution to this equation and the solution to that equation should be the same. So I think negative 15 is my guy, and just to make sure I didn't make an arithmetic mistake, I'm going to check negative 15 plus 6 times, okay, there's where I need to put in my number that I got, negative 15. I want to know, is that equal to 7 times negative 15? Well, let us see, right? So this is negative 15. 6 times negative 15 is 3 times negative 30, which is negative 90. Okay, so negative 15 plus negative 90. 7 times 15 is negative, or 7 times positive 15 is 70, plus 35 is 105. I need that negative, so negative 105. Okay, let's see, is this equation true? If I'm at negative 15 and I go down 90, 90 plus 15 is 105. Now it's both headed in the same direction, so negative 105 equals negative 105. Yes, so I go back and I know for sure negative 15 is a root of negative 15 plus 6x equals 7x. Right? It's a solution. It satisfies that equation.